And I'm also going to start recording.
Bueno, muchas gracias a todas las personas que están ingresando a esta sesión, a este seminario web. También saludos a las personas que van a ver esta grabación después. Vamos a dar unos minutos para iniciar mientras más personas se conectan. Gracias, Becky, por poner la información en la pantalla. Muy bien, ya casi estamos listos para iniciar. Si quieren, pueden irse poniendo cómodos. Ahorita vamos a comenzar con nuestro seminario web de esta mañana. Un placer estar con ustedes el día de hoy. Ya casi vamos. Bueno, por lo menos podemos ir viendo temas técnicos. La actividad de hoy cuenta con interpretación simultánea en inglés y en español. Esto, para tenerlo, tienen que activarla. Hay un botón de interpretación disponible en la pantalla de Zoom que ustedes pueden marcar para poder, ya sea escuchar la interpretación en inglés o en español o desactivar.
That's fine.
Perfecto. Muy bien, yo creo que veo que ya se está estabilizando la cantidad de personas conectadas. Un gusto que nos acompañen el día de hoy. Muchísimas gracias por unirse en este taller, el tercer taller Riquezas Naturales de Costa Rica, mapeo y modelación de la biodiversidad y sus contribuciones a la sociedad utilizando observaciones de la tierra. Aquí en la pantalla pueden ver la cantidad de organizaciones que nos hemos involucrado en este proceso. Ahorita que voy a dar una bienvenida, voy a hablar de esto. Becky, si quieres pasamos a la siguiente filmina. Gracias. Les agradecemos. Este va a ser un taller práctico, eso es muy importante. Vamos a tener una parte introductoria, pero lo más importante va a ser que ustedes puedan aprender a hacer uso de varias de las herramientas que se van a compartir el día de hoy. Entonces, les agradecemos mucho que si quieren hacer preguntas a los ponentes, puedan hacerlas utilizando ahí la sección de preguntas. Así quedan registradas y es más fácil darle seguimiento a las respuestas. Y si quieren ver temas de logística del webinar o asistencia técnica, también pueden utilizar el chat, ¿verdad? Entonces, esto es para los temas de cómo podemos comunicarnos. Utilicemos estos canales que tenemos en esta plataforma para poder generar las preguntas, ya sea los temas de contenidos, ¿verdad? En la parte de preguntas, o cualquier cosa de logística, podemos usar el chat.
Can I make an interjection really quick? So I just wanted to say, during the hands-on portion, if you do want to unmute, we can do that. You can put your question in the Q&A, and then we can let you unmute so that we can talk live. Go ahead, Rafa.
Gracias. Seguimos con la siguiente diapositiva. Muy bien, entonces, el plan de hoy es hacer una introducción de comentarios iniciales conmigo en representación del Ministerio de Ambiente y Energía y también con Cindy Schmidt de la NASA, Program Manager de la NASA. Después vamos a tener una presentaciones sobre el modelado y seguidamente será la parte de la capacitación técnica en donde se va a hacer la corrida del código. Y muy importante, ¿verdad? Que todos tengan una cuenta en Google Earth Engine para que puedan seguir esta parte. Ahí está el enlace para poder entrar a esta parte por si gustan ir haciendo esa gestión. Entonces ya damos inicio con la parte inicial. Ok. Ya estoy grabando. Muy bien, muy bien. Excelente, yo creo que ya estamos listos para empezar con este plan del día, si gustan. Como esto es Becky, usamos esta filmina, quitamos. Ajá.
Okay, sorry.
No worries. Mi rol ahorita es ayudar a hacer estos comentarios iniciales y presentarles también a las personas que estarán compartiendo con nosotros el día de hoy. Voy a hacer esto muy, muy práctico, muy dirigido para contextualizar un poco el trabajo que se está haciendo y poder escuchar primero a Cindy y después ya a nuestras ponentes, Becky y Linkin, ¿verdad? Desde el Ministerio de Ambiente y Energía, particularmente el Centro Nacional de Información Geoambiental, que es la oficina que yo coordino en el MINAE, hemos estado trabajando en este proyecto junto con The Natural Capital Project de la Universidad de Stanford, que está dirigido a mejorar la manera como se hace la modelación de servicios ecosistémicos utilizando las observaciones de la Tierra. Esto en Costa Rica se ha venido implementando en conjunto con el Banco Central de Costa Rica y el laboratorio PRIAS del Centro Nacional de Alta Tecnología. Y cuenta con el apoyo de la NASA, ¿verdad? También del Grupo de Observaciones de la Tierra y de esta iniciativa GeoBond, del Grupo de Observaciones de la Tierra sobre el tema de observaciones de la biodiversidad, que ha venido con quienes han sido todos estos socios con que se ha venido trabajando en esta iniciativa. Este es el tercer y último taller técnico que se realiza. Hemos hecho dos actividades. La primera fue muy bonita porque fue presencial en Costa Rica, en donde nos visitó el equipo de Stanford y nos conocimos. Fue bastante interesante, un periodo antes de la pandemia, fue un inicio del proyecto donde empezamos a conocer de qué se trataba la iniciativa. Ya posteriormente se hizo un segundo taller, por cierto, toda la información de ese segundo taller está disponible, la grabación, hay comunicados y las presentaciones las tendremos en nuestro sitio web del CIMOCUTE, el Sistema Nacional de Monitoreo de la Cobertura y Uso de la Tierra y Ecosistemas, que es esta plataforma de coordinación que tenemos en Costa Rica para manejar todo este tipo de gestión de la información espacial para la toma de decisiones. Entonces, en el marco del CIMOCUTE, desarrollamos este proyecto y además toda esta información se hace disponible por medio de esta plataforma. Ahí teníamos todo lo del segundo taller y hoy es la oportunidad de conocer este tercer taller, pero ya dirigido en hacer un ejercicio práctico, ¿verdad? Ya la idea es desarrollar conocimientos en todas las personas que que nos acompañen el día de hoy o quienes vayan a ver estas grabaciones y puedan desarrollar los análisis ustedes mismos. Aprovecho para agradecer demasiado al equipo de Stanford, al equipo de los socios del proyecto, y procedo a dar la palabra a Cindy Schmidt, representante de la NASA, quien ha sido nuestro enlace en el desarrollo de esta iniciativa con la Agencia Espacial de los Estados Unidos, quien nos acompaña hoy para dar una breve bienvenida. Adelante, Cindy.
Great. Thank you so much, Rafa, for inviting me to give a short.
Can I just interject, because we've had quite a few more people join since Rafa began his remarks. I just want to remind everyone that we have interpretation. And so if you would like to be hearing Cindy's remarks and our presentations in Spanish, you can go to the interpretation button and click Spanish instead of English. Okay, thank you. Just wanted to make sure everyone knew that.
Great. Thank you, Becky. That's one thing I really love about Zoom, right? It's so easy to get the translations done versus some of the other platforms we have to use. So anyway, thank you for that. And good morning, everyone. My name is Cindy Schmidt, and I'm an associate program manager for NASA's Ecological Forecasting Program, and have worked with Becky and Rafa for the past 3 years or 4 years, maybe 3 or 4 years. I've lost track, Becky, as the kind of the interface between the project and NASA headquarters. So I realized that this project is coming to an end. So I really wanted to reflect on what NASA's original solicitation requested and how much this project has succeeded in exceeding our expectations, particularly given the challenges of working during this global pandemic. The original solicitation requested for proposals to apply, test, demonstrate, and enable sustained uses of Earth observation-enabled essential biodiversity variables under GeoBond to support countries' obligations under various environmental global reporting requirements, such as the CBD or SDGs. So that was the original solicitation. This project not only developed models to use Earth observations of ecosystem level essential biodiversity variables for Costa Rica, but also developed models to use those EBVs to predict ecosystem services. And not just one ecosystem service, 4 of them. And so NASA recognized this as really an exemplary project that has not only made important scientific findings, but has been used to pilot Costa Rica's ecosystem service accounting system. And this project would not have been successful without the amazing commitment from Costa Rica to be global leaders in biodiversity conservation and natural resource planning. This workshop is the culmination of all of this amazing work. And while I know we would have all preferred to have held it in person, I know I would have preferred that. I'm so excited that you're able to learn about how to use Google Earth Engine to conduct ecosystem service modeling. So at this point, I'll turn it back over to Rafa, but thank you again for giving me this opportunity to talk with you this morning, and best of luck on the workshop. Thanks, Rafa.
No, gracias a usted, Cindy, por sus palabras y por todo el apoyo que hemos tenido de parte suya personalmente y también de la institución a la que usted representa. La NASA ha colaborado mucho con Costa Rica en este proyecto, en otros proyectos que tenemos con PNUD, de mapeo de la naturaleza, SICA, el Sistema de Integración Centroamericano, recibe un gran apoyo de la NASA en diferentes proyectos de temas muy importantes, pero bueno, hoy nos vamos a enfocar en el tema de servicios ecosistémicos y este proyecto de modelación que hemos desarrollado con el apoyo de NatCap y de la Universidad de Stanford. Y por eso Ahora me corresponde y tengo el honor de presentarles a Becky Chaplin Kramer y a Ling Liu, que van a ser las personas ponentes de este taller. Becky es investigadora principal de la Universidad de Minnesota y de la Universidad de Stanford, donde dirige el desarrollo de modelos globales de servicios ecosistémicos para The Natural Capital Project. También es cofundadora y directora ejecutiva de la organización tecnológica sin fines de lucro Spring, y que crea soluciones de software para la investigación y resolución de problemas medioambientales. Ha sido autora principal y coordinadora de la evaluación de valores de la plataforma intergubernamental científico-política de diversidad biológica y servicios de los ecosistemas, o IPBES o IPBES, como no sé cómo le digan ustedes, y forma parte del grupo de trabajo sobre conocimiento y datos de IPBES y del grupo de trabajo sobre servicios ecosistémicos de la red de observación de la biodiversidad y del grupo de observaciones de la Tierra, de GeoBond. Ella tuvo su doctorado en Ciencias Políticas y Gestión Medioambiental de la Universidad de California en Berkeley. Y como les decía, también tenemos a Ling Liu, que es investigadora científica de datos especializados, investigadora especializada en el uso de datos de observación de la Tierra para la gestión de servicios ecosistémicos. Ha trabajado en proyectos que identifican las soluciones para utilizar los productos de observación de la Tierra en INVEST. Anteriormente, ella trabajó como becaria postdoctoral del Centro de Excelencia de Ciencias Geoespaciales de la Universidad de Dakota del Sur, donde desarrolló la elaboración de un producto fenológico global de la superficie de la Tierra terrestre para la NASA. Ella obtuvo su doctorado en cartografía y sistemas de información geográfica en el Instituto de Detección y Tierra Digital de la Academia China de Ciencias, y entre sus intereses de investigación incluyen la geografía, la teledetección, los sistemas de información geográfica, la fenología de la superficie terrestre y la dinámica de la superficie terrestre y su respuesta a los cambios globales ambientales. Muchísimas gracias de verdad por estar el día de hoy con nosotros, preparar estos contenidos. Te doy la palabra, Becky, para que continúes el seminario.
Thank you so much, Rafa. It's such a pleasure to be ending our time together, which I hope will just lead to new beginnings and new work that we can dream of together. But winding up this project on improving the linkages between Earth observations and ecosystem services modeling, I would like to just take a moment to introduce you to the Natural Capital Project, if you haven't seen it before. Our mission is pioneering science, technology, and partnerships that enable people and nature to thrive. And we do that through the development of cutting-edge science and new technology, including what we're going to be presenting today on bringing advanced satellite information into ecosystem service modeling, as well as partnerships with decision makers and local stakeholders, such as we have done here, and hopefully in the end, all of this culminating into impact for people and the planet. Our core foundation is looking at ecosystem service modeling, and specifically so that we can represent how changes in ecosystems lead to changes in ecosystem services and their values, the values of nature to people. And we do this through INVEST, the integrated valuation of ecosystem services and trade-offs, a software that's free and open source and you can download today. And when we first started talking to Rafa and other partners in this project, we identified a number of different contexts in which this information would be valuable. And I have to say the list has just grown and grown over the course of the project. And Rafa has done an amazing job of plugging this information into new and exciting opportunities that continue to emerge. Costa Rica is such a leader in sustainable development for the world, a great model that the rest of the world could follow. And these are just a few of the opportunities that Rafa identified that ecosystem service modeling, especially with improvements from Earth observations and the essential biodiversity variables and essential ecosystem service variables that GeoBon has developed, how those could plug into these programs. So I want to start first from a frame of why did we even do this? What was the problem? And that was just that when we think about our world in terms of categorical land covers, we miss a lot of what's real about the way the world looks. And what's happening there is that we oversimplify in terms of seeing a forest as homogeneous across space, when in fact we know that there's a lot of heterogeneity in condition and function within that single habitat type that we're missing when we just represent it in terms of categorical land cover. That could mean that our modeling of the functions and the benefits that flow to people are inaccurate. And on top of that, it's often really difficult to parameterize these models because in any new situation, you need to go back to the literature to find values that correspond to those land cover types, which is one of the big barriers to mainstreaming these approaches and doing them more widely. So we thought that if we could address some of these problems, we could see a much greater adoption of ecosystem service modeling, but also a better representation of the changes and spatial variability that we actually see in the world. So our solution then is by using advances in Earth observations, moving beyond land use, land cover, we will have models and outputs that information that can be used in decisions that is more relevant in terms of the values being clearly attributed to ecosystems, more accurate in terms of better representing patterns observed on the ground, and more accessible, making it open and easily replicable because these Earth observations, unlike literature review, are globally available. And so the approaches that we use here in Costa Rica could be applied anywhere. So this is our theory of how to change the inputs here. Instead of land cover, we're using different kinds of Earth observations. I wonder if, can you see my mouse? I could try to annotate, but different forms of observations of ecosystems that come from satellites. So we might see fractional cover, or in this case, what we're focusing on today is EVI, the Enhanced Vegetation Index, that tells us something about ecosystem structure or function, and that can be linked to habitat, for instance, for pollinators, or it can be combined with other satellite information on precipitation and topography and temperature to get us to understand better about species distributions, which also can be included in pollination modeling. But along with that, we can take the same sorts of ecosystem observations and combine them with climate to get directly to ecosystem service supply through something like control of erosion, sediment regulation. And all of these are really improving the supply of ecosystem services. And then bringing in Earth observations can also inform demand in terms of where people get their water from or where farms are. That really, when you put the supply and demand together, is when you get the ecosystem service to people. And so we advanced the modeling of pollination here and sediment retention or water quality regulation, and also nature-based tourism, which we won't be talking about today, but I can link you to more information on that.
Más información al respecto.
Rafa, did you want to say something? Oh, okay.
Sorry, go ahead.
Okay, no problem. So the first one that I'll give you a little overview of is water quality regulation. And in this case, it uses slope and soil erodibility, rainfall, erosivity, and then some coefficients, like I was talking about before, based on land cover, that we're improving. That is the cover factor, or C factor, and management factor, which is called the P factor. And together, all of those variables that are spatially explicit, so taking many different maps of these different variables, we put into a soil loss equation that kind of brings those all together, and then route it through the landscape so that we can look at the area upslope of a particular pixel, as well as the downslope path to a river, and understand on every pixel over the landscape how much sediment is being retained there by the management and landscape characteristics, the vegetation characteristics. And that gives us the sediment delivery ratio that we're modeling. And by using the soil loss equation and the sediment delivery ratio, we get the total sediment export to the stream. And that's what affects our water quality to downstream beneficiaries. So that's a typical way, is that cover factor would be defined by land cover types. And I apologize, this table is in English, but in general, here is just your land cover classes, different ecosystem types, and you set different values. So forest everywhere is the same value. But here we're replacing it with EVI to say that it doesn't matter if you're a degraded forest or a really pristine, maybe shrubland. We don't see those distinctions. We see the actual condition of the ecosystem. And where there's less cover, there's less sediment being retained. And where there's more productivity or greenness, there's more action by the vegetation to trap the sediment or to block the action of the rain to erode the ground. And what we found here is that this produces really different patterns, as you would expect, of the expected C factor, and therefore the expected sediment retention. So if you take just a little watershed like this and you see, forest looks very heterogeneous, and a landscape with, for instance, agriculture in it looks very, very heterogeneous. When you're just looking at land cover, it just looks like all the same thing, just very blocky. But when you look at the Enhanced Vegetation Index, you can start to see the real variability across space. And so we looked at that, and in this case, we've looked at the minimum EVI, but we've also looked at different percentiles of EVI to avoid noise in the sensor that occurs at the very most minimum. And so if you take the low percentiles, like here we're looking at the 20th percentile over the growing season of EVI, that's when the land is least productive and maybe where the sediment erosion is most likely to happen. So the capacity of the ecosystem to hold back sediment, you should judge on the least productive time of the year. So we took that, and if we look at that low EVI time of year for these different land cover classes, we see the same kind of relationship that we expect to see with C factor, where C factor is very low, very, very low for a forest, and very, very high, close to 1 for bare ground. But it has this sort of exponential relationship. Actually, we found what fit it best is called a Poisson relationship or distribution. And so these are different values that you can play with. And I'm going to run through the code with you today to show you that you can set different parameters to give you different relationships between the EVI and the C factor. And you can play with that to see which one gives you the most accurate results. I think, did we get a question just now? Nope. Okay, never mind. I thought I saw a question. Okay. Feel free to ask questions along the way though. So this is our approach, is we take the EVI and we apply this transformation so that we can get a C factor. And then we have a C factor raster that we can plug into the sediment model. And what that results in is sediment loss that looks a lot different. So this is based on land cover, and you can see this top figure is a lot blockier, and it because it's showing dramatic changes between forest and not forest right next to it. Whereas the pattern for EVI based on, the pattern for sediment export based on EVI has more heterogeneity and looks more realistic. It looks more like a landscape. It results in really different patterns. So here in this green and pink, this is where the pink areas are where EVI predicts much higher sediment export, and the green areas is where EVI predicts much lower sediment export. And that's important from a decision-making standpoint, because if you're targeting where you want to have management interventions and you've gotten wrong how much a certain part, like here, contributes to sediment export, you might direct your intervention to the wrong places. So getting a more accurate pattern really helps us in sustainable development to plan for the most important places that contribute the most to improving ecosystem services. And what we found here is that doing this actually is far more accurate. So it really overestimates less. And here we see, again, the pink is the overestimate. And for land cover, we see many more watersheds that have much higher overestimates compared to observed sediment export that came from water data that ICE, the water company, shared with us. So we were able to validate this across 50 gauges across the country. Okay, so now moving into pollination. The basic idea for pollination is that we look again, on a pixel by pixel basis over a landscape where a particular pollinator could fly in order to pollinate crops. And in order to understand that, you need to understand how far the pollinators can fly, what their foraging distance is, or their flight range, but also what are the resources that they need to access, because pollinators can't often live in the crop alone. They need additional floral resources in the surrounding landscape, as well as nesting habitat where they can live. And so by having more resources in the landscape, you can get a higher pollinator availability and greater pollination services. So the typical way that we used to do this is by thinking about, okay, again, from a land cover perspective, these different habitat types would have different ground nesting capabilities, different cavity nesting resources, which is when pollinators have their nests in the cavities of trees and stems. And so those are different kinds of bees that would nest in different places. And so both are needed opportunities. And we tend to not see a lot of cavities available in crop fields. The ground in crop fields tends to be very disrupted. So ground nesting bees can't nest there. So again, these surrounding habitats around the farm are really important. They also need floral resources when maybe the crop isn't blooming. And so thinking about when are things flowering in the spring, in the summer, when the bees are active. And in the land cover style, we look at as though all forest has the same amount of ground nesting and cavity nesting opportunities. All forest has the same amount of floral resources, which is really a vast oversimplification when we know that forests really differ in their diversity and how many resources might be available based on that diversity. So, oh, I see now the question. Will the presentations be recorded? Yes, they're going to be recorded and shared afterwards. We will post them to the Simakute site. So this imperfect way of representing pollinator habitats through land cover, which by the way it's really hard to decide how to set these parameters. And this is one of the reasons that this model tends to not get used except by experts. It's very difficult to actually use by decision makers. So we wanted to lift some of that burden of how would I set these numbers and replace this with, again, based on EVI, the diversity of the ecosystems, ecosystem functional diversity, assuming that a higher diversity means greater resource availability. And so therefore, as we increase the number of functional types that a pollinator has access to, we also would see more, we could see it at like a higher amount of nesting and floral resources. And what we expect then is we're going to be showing you today how to map ecosystem functional types. Ling will be explaining that in more detail and then running you through the code. And I just want to say here that in our very first meeting when we came to Costa Rica a few years ago, this was the #1 ask that we heard from several of the different branches of the ministry was they just wanted ecosystem maps. So it wasn't even necessarily that they needed ecosystem services yet, but they were really hung up on getting not just forest, not just land cover, but ecosystem maps. And so I think beyond even just using this in pollination or other kind of ecosystem service modeling, the ecosystem functional type maps themselves might be interesting and useful for some of you to look at. But the idea here then is if each one of these colors is a distinct ecosystem type, then where you see areas where there's lots of different ones would be higher diversity, and where there's fewer is lower diversity. And so we can map that diversity, the amount of types, which Ling will explain, but we then get a map of ecosystem functional diversity that we can put into the pollination model. And what we find there is that when we predict pollinator availability using this diversity, it's both higher in many places than predicted by land use alone, and that higher availability is more accurate, especially reducing the underestimates. This bar in gray is how often land cover approaches to mapping pollinators underestimates pollinator availability compared to using ecosystem functional diversity. And again, that's really important from a management perspective, because if you aren't appreciating how many pollinators are being provided to you for free by nature, then you might make land use decisions that put those pollinators in jeopardy and could really reduce crop yields as a result. Okay, the last thing is just, before I turn over to Ling, because she's going to pick up from there and tell you about ecosystem functional diversity, but I just wanted to recognize that all of these that we're talking about are free and open source. Invest has a ton of models in it already. We just picked a few to try to begin to improve. And I think we're really excited about the work that we've done here, and we want to continue to look at other ecosystem service models as well. We're in the process of publishing these results, and so they aren't yet in the Invest software suite because we do require that bar of credibility of peer review before we release a model in the formally supported software suite. So you won't see it yet if you go to the Invest software, but we do have these implementations available in code in Python. So we're not going to be training on the Python today. We're going to be training on the Google Earth Engine techniques that we developed in order to produce the inputs, the C factor, the raster EVI C factor, and the ecosystem functional types and ecosystem functional diversity. And then those inputs that you create through Google Earth Engine can be brought into these implementations that will ultimately be showing up in Invest when they get published. So thanks so much. That's our overview of the two main models. Again, I can talk to you more about our tourism model. It's a bit more complex, but we would be happy to share we have a paper on that coming out in PNAS, Proceedings of the National Academy of Sciences, later this week, I think. So I'm going to stop there and turn over to Ling Ling to pick it up from pollination and ecosystem functional diversity.
Thank you, Becky. I'm going to share my screen. Here we are. Good morning, everyone. So now I will go into more detail on how we map ecosystem functional diversity. As you saw in Becky's presentation, we use the ecosystem functional diversity modeling to replace land cover in crop pollination model. As before, we can calculate ecosystem functional diversity. We need to map ecosystem functional types. So because we need to count the number of how many ecosystem functional types in the area to get the diversity. Before talking about the entire workflow, I want to introduce what's the ecosystem functional attributes, because we derive the ecosystem functional types based on these ecosystem functional attributes. Totally, we calculated 11 types ecosystem functional attributes from the phenological curve of the for example, the different vegetation types. Here, this figure shows from January to December, how EVI changed during the year. From this curve, we calculate 11 EFAs. It includes the mean EVI. It represents the annual primary productivity. We also calculated the standard deviation of the EVI during the year, or coefficient of variation. So the coefficient of variation, the EVI, it equal to standard deviation divided by mean. We also calculate the greening time, at the start of the growing season, also corresponding to the vegetation index. We also identify where it is the maximum EVI and the date of the maximum EVI itself. Also the minimum EVI and the date. We also calculated the browning time and the corresponding EVI at the browning time. Here we have a workflow to show how we calculate the EFT, ecosystem functional types, the step by step using Google Earth Engine platform. So our input data to derive the EFT, our input data, it is you can either using multis or land-side EVI. Here we in our study we're using the time period from 2001 to 2017 because it is land-side data we use on Google Earth Engine platform are available during this time period. Also, it is enough years, I mean multiple years can represent the ecosystem functional characteristics well on the landscape. By using this data, we did two things. the first thing, we run principal component analysis for dimensional reduction to get the most useful information. The second thing we did, like I just talked about in previous slide, the EFAs, we calculate all 11 types of EFA, like including mean, standard deviation, and so on. After we get the most important principal components and like the ecosystem functional attributes, we calculate the Pearson correlation between the three most important pieces and EFAs for looking for like the which EFA can represent well the most important pieces. Here I want to add, we only focus on the first three pieces because it could represent more than 99% variations. At the same time, to avoid it, to choose very highly correlated EFAs, we also run auto-correlation test among the EFAs to exclude the highly correlated EFAs. By doing this, we can decide the three most important informative and independent EFAs. We are going to using the EFAs for each EFA, we are going to divide it a few classes. It depends on the study area and the the phenological cycle in the study area for grouping into different EFT. Yeah, after we get the EFT, we can calculate the EFD. Yeah. So the table and the bottom show like the correlation, Pearson correlation between the three important pieces and EFAs. In the red box, you can see like for example, PC1 and all the EFAs, you can see in the red box, mean has the highest correlation between PC1 and the mean. Yeah, similarly, yeah, PC2 has the highest correlation with the SD, and the PC3 has the highest correlation with the data of the maximum EVI. So that's the reason, we chose these three. Yeah, to remind you, yeah, these are like these three EFA showing on this figure, like the mean and the data of the maximum EVI and the standard deviation. Yeah, it is the three we picked up based on all the analysis for further deriving the EFT. These figures we show how do we set breaks for grouping into different categories to derive the EFT. On the left one, like for example, mean, we can use the 50 percentile, like this red line here, the 50 percentile to divide it into two groups. And for standard deviation, we also using the 50 percentile to divide the two groups. But for phenology variable, data, sorry for mistake, it should be data of the maximum EVI. So this one, it is a bit different because this one, it is a circular variable. In our study area, we chose like the, so 125 to 300, like the 300 maybe 20 here. This one, this box, within this box as one group, the rest as a second group, like the between number one, the day 1 to 120 and the 320 to the 365. Like I mentioned, it is a circular variable. It means like the last day 365. It is just next day. It is day 1. Here, we derived the EFT using both MODIS and Landsat because we want to see if the two sensors produce different patterns. We also like the A and B, it is the A from the MODIS and the B from the Landsat. Yeah, we did see some similar pattern, but we also see some difference. Yeah, we also repeat at the subnational scale, like the Nicoya Peninsula, to see how different the EFT when we derived from different scales. Yeah, this figure, I want to show how did we derive the ecosystem functional diversity based on the EFT we just talked about. For example, MODIS data, we are using like the resolution around 230 meters, and we're using 5 by 5 window size to calculate around like the 1 kilometers. This buffer zone, like the what's the diversity looks like. So in this window size, on the left figure, we can see in this window size, there are 5 different numbers. It means there are 5 different ecosystem functional types in this area. So we're using number 5 to represent the diversity. Here is like the how do we using the window size to calculate the EFD. We can also choosing using different window size. For example, we can using 1 kilometer, 2 kilometer, or another one. It depends on like the research question you propose. Yeah, so it has the flexibility here. Yeah, so I want to say like the in the coastal resolution EFD. Yeah, so it is the higher diversity. Like in the right bottom one figure, you can see compared to like the right top figure, like 1 kilometer. Yeah, so this is about the how do we map the EFT? Yes, step by step. Yeah, so probably the backend. So the next step, I'm going to show the code, or you'll show the SDR first. Thank you.
I think you can jump into the code, and let's just remind people of the where they need to register. So I'm going to put that in the chat again. Okay, so it's at code.earthengine.google. If you go there, and if you don't already have an account, you can sign up using Gmail, or and I think you can create another account on the fly. And then Ling, do you want to put the code to the repository? You got it already. Okay, perfect. So that should allow anyone to view the repository that has all the scripts in it. And I wonder if before we go into the code, if you do have any questions, we're going to give people an opportunity to get situated there. Ling, you can share your screen and bring up what the code looks like, what Google Earth Engine looks like.
Okay.
And if anyone has any questions about any of the material, we can also pause to answer those if you want to put them into the Q&A, or if you prefer to raise your hand. And we'll just wait a couple minutes for people to get oriented to Google Earth Engine, and you can ask some questions if you have them, and then we'll begin. So Rafa, I don't know if you want to address Ivan's comment about this opportunity.
Sí, I can comment on Ivan's question. I can do it in the chat if you want, but yeah.
Okay, that's fine. That's fine.
Yeah, we can organize something specific for ICE. They are one of our most important stakeholders too.
Yeah.
Providers of information as well. So it would be great to give this feedback.
Absolutely.
Becky, I'm going to do this in Spanish. Si
Yes.
pego esta dirección que puso en el chat, me va a salir en la pantalla esto que tiene link, porque lo hice y no me muestra el código. En mi...
Okay.
No sé cómo está.
What is it showing you?
Blank.
Blank?
Yeah.
Okay, let's try. Ling Ling, do you want to try sending them the individual script?
So one thing I want to add, if you can go to the reader, probably you can find it in the reader. There's a folder. I tried yesterday using different account.
Okay.
Yeah, so can you find in the reader, and there is a folder should be called workflow.
Is that showing up for?
Yeah, if you couldn't show, I can, yes, send them the, I think I can send them both. Yeah. So this is individual one.
I'm also going to try, Ling Ling, I'm going to try just sending the link to the code directly.
Yeah, I send them both.
Okay,
So,
great.
yeah, both way. One it is a repo, another one individual script. Probably just a simple click the link.
Okay.
Yeah, it works from here. It works.
So yeah, the one that Ling Ling put in the chat, yeah, it worked.
Okay, good.
Gracias, Johan, por confirmar.
Okay. So then I think, great. I think we're ready, Ling Ling, if you want to go ahead.
Okay, so for the code, I'm going to show the two code. The first one, I'm going to introduce the code called Modis EFS bricks. Probably you don't have this name, but
Ling Ling, can you also make your map down below on Costa Rica? Because that's where everything will show up. And you can zoom in a little bit. Perfect. Thanks. So that's just for everyone to know. That's how you can just drag the map around different places, and you can use your scroll wheel to zoom in and out, or you can use the buttons off to the side. go ahead.
Yeah, thank you for reminding this. We are talking about Costa Rica. So this is the first code. Like this code can derive the ecosystem function attributes and calculate the breaks. So to remind you, I want to go back here a little bit. Like we just talked about the 11 ecosystem functional attributes. So because we base this EFAs to derive the EFT, and I also mention how do we set breaks here. So in this code, I will this code can do this work for us. And how about we just do a simple the test run to see what will happen. So that will give you more details. You can click the run. Yes, on the bottom there is a run button. So, oh, sorry. So I should go back to this code. So why open tool? Let me close this one. Oh, this is the first one. Let's click this one. You will let me. As you see from the console panel, you see 3 histogram here, and these 3 histogram also the one we just look at from the slides. So we based on these 3 histogram, and so this is the same like the 3 histogram. We based on this 3 histogram and choose the breaks, and can generate the breaks at the bottom here, like the mean breaks. So we can calculate the mean breaks here and the standard deviation breaks here. And for the data of the maximum, like I mentioned, we divided into the groups based on like its seasonal changes. Another thing you might want to say what spatial pattern maps of the EFA looks like. So if you go to the maps at the below, there is a layers here. If you put your mouse on the layers, you can see all the 11 EFAs. We generate based on this code. So like for example, if you click the mean, you will see the map like the about the what's the spatial pattern of the mean looks like, standard deviation, coefficient of the variation, the maximum vegetation index, data of the maximum EVI, also the minimum, the date, like the browning, like the end of growing season vegetation index, browning time, greening vegetation index also correspond to the dates. So
Lillian, could you show us the graph again, just really quick, go back to that slide where you show the curve. Slide 4.
Okay.
Yeah, perfect. So just these are the different aspects of the phenology that she's showing right now. So you can map each one of these, and that's what we're trying to correlate with the principal components.
Yes.
I just wanted them to remember.
Yeah. So it is very important to correlate everything. So I think this code, this mean code, you can say, like I just talked about these 3 things: histogram. We can choose the breaks from the histogram. So we can also see spatial pattern maps. So for this code, you might wonder, okay, if I only focus on Nicoya Peninsula or the area I'm interested in, how can I change the code? if I only focus on the 2010 to 2020, so how do I use this code? So yeah, I think this code definitely provide this flexibility. You can change the study area you are focusing on, the study period you are focusing on, where you are interested. Let's first talk about the study period. For this code, for the line number 12 and 13, you see the first year and the last year. It represents the first year of your study period and the last year of your study period. If you focus on only 2010 to 2020, you can change this one like the 2010 and this one 2020. And also you might only say, or you say, oh no, I only focus on my local study area. So you can, if you have the boundary of your study area, you can simply upload your zip file, like the, for example, you can table upload, it includes the zip file. Yeah, you can simply upload your zip file here and here. For make it more simple, we can just simply draw a polygon, for example, Nicoya Peninsula. Yeah, you can see here. Yeah, so probably I can using the annotation like the here. You see this code add a geometry like the yeah, so it add a geometry. It represents the area we just choose. So you may say, oh, you like the if I using this polygon, it cover both land and the water. So no worry about the water area. So this code has the ability to mask the water area, only calculate the land area that we care about or we are interested in. So another thing like the after you add this new area, so you can simply comment this land. This land is the area for Costa Rica, and this land, it is the one we just choose. It means by doing this, it means right now your study area only the area you just like the draw. So
yeah, so just to specify here, anything with these / in green, that turns it into the code not seeing it. It becomes just a comment. So that's what Ling Ling meant about commenting it out. So if you want this to be active, here, I'll annotate really quick. Okay. If you want this one to be active, you uncomment it. And if you want this one to be active, so if you want to use just this geometry, you take off the //. The / is what makes the code not read it. Okay, sorry, go ahead.
Thank you for clarifying. It is very important because I thought, I know, yeah, so comment, yeah, on my code. Yeah, so the next step, you first want to save the changes you just made. Yeah. When this button became the gray, you can click the run again. Yeah, here you will see, like the different patterns, like it still will generate the 3 histogram, but you see the patterns is already different because we just generate based on the new study area we care about. Also the new breaks, also break for mean and standard deviation. Like I mentioned, the data of the maximum we need to choose based on this one. I mean, like because more seasonal, it choose by like I think I want to emphasize the mean and standard deviation. It is 50 percentile. So it is very simply generated using the algorithm from the Google Earth Engine. But for data of the maximum, we need to kind of choose by based on our the knowledge on the study area. Like this one, you might want to like the choose between. I can probably I want to add it. Yeah, so maybe this one you want to put as one group, the rest one as another group, like this one. The left part and the right part, you want to as a second group and the middle one as a first group. So this one, like after looking at the histogram, and then you will know. So I mean, like it couldn't like using some simple algorithm in the code. You need to look at and to determine like okay, this is bricks. This is the bricks, so you can use it in the like the next code. Thank you, Becky. Yeah, I think for one more thing I want to say. Yeah, so if you go to the task panel, you will see all the 11 EFAs are here. Yeah, so if you want to export like the to your local drive or Google Drive, for example, we can simply choose one. You can click run button on the right, and in this dialog, you can change the task name. You can you can choose your own folder. Yeah, you can even choose the format. Usually, yeah, we're using the GeoTIFF. You can also put it in the Google Earth Engine asset. So Google Earth Engine asset, it means it will go to the before the asset, it will go to the asset we just talked about. Yeah, so it's very easy to call into using another script. So you can simply click run here. So just I need to put the asset ID here. Yeah, you can simply click run. You will find here. Yeah, so you see this one is different from other one because it is running. Yeah, it might take several minutes to get the results. Yeah.
And when it does, Ling, can you show us in the assets tab where it shows up once it's done, and how you would load it into, like if you wanted to look at it and compare? This actually I think would be great if people want to try running it at a national scale and then running it for their own area of interest within Costa Rica. Then they can look at the differences side by side if they have them both in their assets, and maybe you could show us that. Once it's finished, we can come back to it.
Sure. Yeah, let's it run by itself. We will come back later in a few minutes. So I think another thing I want to show you, it is, yeah, so you also say, that's how to do this one. Okay, yeah. So you will say all these 11 EFAs only show the study area we just draw. Yeah, so I think I also want to show the difference of this, like the still, yeah, only generated the area we just draw. It means like the area of the interest. Oh yeah, after showing this, like the this run is already done.
Awesome.
Yeah, we go to the assets. Sometimes you need to refresh your assets. Yeah, after I refresh my assets, you can say there is a test here. It is just added. Yeah, so here I only want to test it, so I give this name. So you can give the name like the it is easy help you to use in the next step, like to the real meaning of the data.
And Ling Ling, do you want to show them how to rename it? Because maybe you want to rename that one. You could rename it Nicoya Peninsula or something like that, mean EVI. There you go. So you just click that little button.
Yeah, there is the kind of pencil button in the middle one. You saw 3. Yeah, the middle one is the pencil button. Yeah, so how to spell?
Just say NP.
Okay.
And
Yeah.
mean. Yeah. So then we can do it again for the national, and you can put that one there. And then we can show them how to look at both of them.
So national one, we didn't run for national one. We only run for, do you want me run the national one as well?
Yeah, let's try that again.
Okay, the national one. Okay, I need to uncomment here and uncomment the local area. I need to save again.
So hopefully everyone following along can try that as well. And again, if you want to do the geometry, and I'm going to annotate here while this is waiting. And if you just click one of these two, you can draw either an open-ended polygon, or you can just draw a box if that's easier. Try this in a place you know, because I just, you know Costa Rica so well, so much better than us. I would love to hear what people think about places they know, what this looks like to them. So if you do, I wish we were in person because I'd be able to see you all and see if it's working or if you're having problems. If you're having problems, please raise your hand or put it in the Q&A. If it's working for you and you got it to run, please also put that in the Q&A. We would love to know if you were able to get it to run for the country or for a region that you are familiar with.
Yeah, thank you, Becky. So right now the national scale is running. So Becky, do you mean you want me show both maps of the Nicoya Peninsula?
You know what? I just realized for the mean, they're going to be the same because we haven't set the breaks yet. So actually, I think what we should do is wait until we get to the functional diversity and let's compare those. Let's show them how to create an asset and do a comparison. So we'll come back to that. If you want to move on to the next script, you can show them where to collect their breaks information from back on the console.
Okay. Yeah. So this is the second code. Also, the code Becky just mentioned. We can using this code to derive the EFT and the EFD, the types and the diversity.
But, oh, sorry, Ling Ling, I'm sorry. Could you go back to the previous one and just show them where the console reports the breaks for the mean and standard deviation? Yeah, exactly. So you copy those down. And so you can just, you can even just like write them in the code and then copy them over if you want. And then for the date, you're manually deciding based on, and let me annotate again, so you manually decide those are my places, or something like this. It's this one, and then it's the outsides are the breaks there. So you'll have 4 numbers to keep track of that you're going to use in the next script. It's this number, and then like this number and this number. Okay, so those are exactly, thanks Ling Ling. Those are the numbers you want to copy over to here. Does that make sense? And so what Ling Ling is showing is I think from the Nicoya Peninsula. That was what we had previously done. And you'll see these are the ones for the national that are commented out. You can uncomment these. Again, remove these double, those things, remove those double slashes, and you'll see like this one is this one, and this one is this one, right? So I'm going to clear all of those away. But if you want to try running for national first, you can just take those double brackets away and put the double brackets right here. Sorry, the double slashes. Otherwise, you can change these to whatever values you've done over here on your other code. Okay. Hopefully that was clear. Go ahead.
Yeah. Thank you, Becky. Yeah, so this is kind of the breaks that we generated from previous one. Yeah, we are going to use them in this code. Yeah, so how about like the way to test run first to see what will happen. I might want to, yes, already generate. So I might want to comment this one. Yeah. So you might like you might want to know like how can I comment the multiple line at the same time. If you click both the control and the forward slash, you can comment and uncomment for multiple line. Yeah. So the first I want to say that in like the national scale, I uncomment the breaks for national scale. So I'm going to the save. Yeah, save takes time. And I'm going to run. Yeah, so then if we go to the layer, we saw 5 layer here. The 3 EFAs. So I want to go back to slides a little bit to help remind you. So this is a 3 EFAs kind of most correlated with the 3 most important pieces we are using in our code to generate the EFT, like the mean, data of the maximum EVI and standard deviation. Now we go back to the code, like that I show the mean here, standard deviation here, data of the maximum here. Based on these 3 EFAs, also the breaks we just set up. So we can generate the EFT, and we can also generate the EFD. The EFT, you can generate the EFT based on the window size, like I mentioned here, how to generate the EFD. So you can using 5 by 5, you can using 10 by 10, you can using 3 by 3. Yeah, so in this code, if you go to the line number 18, there is a window size. You can just, like here, I set up 3. You can simply change this number 5, like the 10. Yeah, so yeah, whatever you think it will, like the best serve, like your research folks. Yeah, besides the window size, I also want to mention this code is able to generate like the individual year or individual year or a time period, like the EFT or EFD. So if you go to the line number 15 and 16, if you want to generate the individual year, for example, 2010, you can simply change the first year as a 2010, last year also the same year. It means you only generated the EFT and EFT for this individual year. If you want to generate based on a time period, for example, you want to generate between 2010 to 2020, you can simply change this. Yeah, so I'm still going back to the orange.
Hey, Ling Ling, somebody had asked, can we do the can we use just the geometry again? How do we import the geometry again?
Okay. So so since this is a second code, if you change the geometry in the first code, there is one thing you can simply do, like the abandon change. So here, there is a blue box here. There is a geometry. You can simply copy geometry here, copy, and come to the second code. I think probably you can go to here. No, I don't think so. So let me try. So, okay. So you might want to copy the geometry here. So to keep in the same study area, because this code based on the previous one. Does it make sense?
And then can you show where you tell it where you need to change to geometry instead of country? It's right here by AOI. You can show that line too.
Okay, yeah. On the now it is new line number for me. I'm not sure on the previous code, like the just below last year we just talked about. There is a line called variable AOI. You can comment this one. You can simply add another line like the AOI. This is a variable name, I think. Oh, okay. So this one I should add the variable here. Yeah. So this is how do we change it? Changing this line.
Does that make sense? So let's actually let's save that. And I'm realizing when they have read privileges, they can't make changes, can they? Or can they? Are they able to, if they're just reading it, can they actually edit the code and then run a new thing? They just can't save it.
Yeah.
Or they can save it to their, do you want to just show them how they save it to their?
Okay. So let's go to the chat. For example, if I click the link here, so I just send, you can, yeah, so now you see the save button, it is gray, but if you only change a little bit, I mean like that, I only move my mouse a little bit, so the save button becomes the active. So you can just save as, for example, I can save in my this repo EFT and call like EFT.
Rate it. Yeah. Okay.
Test.
Good.
Yeah.
Okay. I just wanted to make sure they had that.
Yeah. Now
and it looks like people have already cloned it, so they're doing fine. So this is great. Thank you for the feedback, because we just don't know where people are at with Google Earth Engine. So if there's anything you don't understand, please stop us. And if we're going too slow, you can tell us, yep, got it.
Yeah. Let me think what I want. Oh, so also the task. Yeah. So I just show you EFD and EFT here.
And so Ling Ling, this is where I think we should save it to the assets so we can compare. So we can compare the EFD Nicoya Peninsula to the EFD for the national scale, and you can show them how to do that.
Sure. Okay, so do you want me save both, like the EFT?
Yeah.
Okay, so
to your assets, I think it would be great to just be able to show them so they don't even have to go into GIS.
Okay, so but one thing I want to make sure correct,
Oh, did you set the brakes? Good point.
Yeah. So. Oops. So rather, I think there is a thing I also want to remind all of you. So when you're using now, like for example, my code using national scale breaks. So I may want to, like the one I want to comment like this local one. I want to come back to my national one. It means when using the when I want to run, when I want to generate the EFT and the EFT for national scale. So you want to make sure your area of interest it is national scale and the bricks also for national scale. Now I have a confidence to run. Yeah, now I think I will go to the I side. So EFT, I will call say, yeah, and then let's run EFT again. So this is for national scale. Yeah, right now, like the national scale are running, so you don't need to worry about like the if I change code, it will influence the result. It won't, because like the right now it running on some cloud form, so it's not related to the code you are currently working on. Now I want to say for the local scale. For the local scale, I want to comment this one, I mean bricks. I want to choose the local bricks. And also for the area of interest, I want to get the area of interest.
Lin, can you remind us how you do that, removing all of them at once? You highlight it and then press what?
Control and the forward slash, if you
Forward slash, okay.
forward slash if you push both. So now I make sure I have the geometry for local scale, and my AOI at the local scale, and my bricks also at the local scale. So now I have a confidence to run. Yeah, so this is a EFT.
Oh, I was going to say EFD. Can you do the diversity? That's the thing I think we really want to. Oh, okay.
Okay, I can do
both.
Yeah.
Great.
Okay. So if we want to save some time, I can also cancel that. This is EFD local. If we want to save some time, only because we more care about the EFT, we can cancel. Becky, do you want me to cancel EFT to save time?
No, it's fine. That's fine.
Okay. It might take maybe more than 10 minutes.
Oh, it might take 10 minutes. Okay.
Because there are 4 tasks here. From my account, it will run one by one, not at the same time.
Oh, they will. Okay. Okay.
Yeah.
Well, that's okay. We can come back to it. Hopefully other people are also running things and then can look at them, and we can pause here for any questions. And then if it hasn't finished by then, I can show them some of the EVI C factor, and we can come back to this. Okay. But I do just want to save some time because we would love to hear from you. If it's working, raise your hand or put in the Q&A. Anything, any feedback you'd like to share? Good or bad?
Sí, muchas gracias. Es un reto, perdón. Hacer esto de la forma como se está haciendo, de verdad, virtual, es muy diferente. Entonces, les agradecemos mucho si nos pueden reaccionar. Las personas que están ahí, bueno, ya veo que hay un comentario. De Manuel, él ya lo clonó. Él va a hacer cambios y lo clona. Great, Manuel. Sé que hay otras personas que con muchas capacidades en el uso de Google Earth Engine en esta llamada. Si tienen de verdad algún tipo de comentario o nada más retroalimentación para saber cómo van, se los agradecemos. Gracias a Manuel que reaccionó por acá.
So I'll just also add, this is an area where we're writing a paper right now on deriving the ecosystem functional type and also the comparing diversity hotspots at different scales. Because obviously the functional types will change when you set the breaks differently at a local versus national scale. But we're hoping that the diversity is fairly robust to choosing the different scales. So if we find diversity hotspots within the Nicoya Peninsula, that they're also hotspots at the national scale. And that's what we're testing right now. If this is an interest of yours, whether or not related to pollination, I just wanted to show you one context where ecosystem functional diversity is useful, but I can think of lots of contexts. In general, functional diversity is really important, as well as just understanding the differences as you move from one ecosystem functional type to another. So if this is an interest of yours, we'd love to hear from you. We'll share our emails at the end, again, as we did at the beginning, but this is an active area of research, and if you are working on similar issues, I think it would be great to collaborate. I see a question. What is the size of the raster product? So what we're showing you right now, purely for the ease of this webinar, is the MODIS, because it runs so much faster. MODIS is 250 meters resolution, but we've also repeated this for Landsat, which is 30 meters resolution. And that was part of what Ling Ling had showed in her presentation, was the comparison between the different sensors, MODIS and Landsat. Thank you, Ling Ling. And so that's the on the left versus on the right. You'll see the patterns are fairly similar, but there are some differences. And then also comparing within the Landsat, we compared within the Nicoya Peninsula, deriving it at that level versus just looking at the national scale zoomed in on the left there. So it's really a flexible approach for resolution, and what I think it mostly requires is a long enough time series to sort of get a feeling for what these long-term, what the functional types look like. So when you're first creating the EFAs and the breaks and doing the principal components analysis, you want this longer term time series. But then in any particular year, when you map the EFTs or the ecosystem functional diversity, you can use those breaks and show it for any year. You can do it in successive years. And Ling Ling, if you want to show the code where you do that, that I think is exciting, because there's now, Sentinel data has been available for a few more years. I think we'd be comfortable applying it to Sentinel as well. And then just so you know, right now on this lines 30 and 31, Ling Ling is running this for the entire time period. So it's kind of a long-term ecosystem functional type or ecosystem functional diversity. But you could also do this for a single year or a smaller period. You could compare ecosystem. That's another thing, that if you want to try comparing different products, you could compare, 2000 to 2005 to 2015 to 2017 or something, and see how did the functional diversity look different in the early 2000s versus later. Okay, I see we have another. Is there another question? No. Are there other questions? Thank you so much for the positive feedback. Okay. So, oh, it looks like some of those are done. We're still waiting on that functional diversity one though. So
Yeah.
maybe we'll come back to that.
Okay.
Okay, so how are people feeling? Do you want a little more time just to work, to try out different things with this code? We could take a few more minutes, or do you, would you like to see the EVI C factor? Tell me in the Q&A and I will do what people tell me to do. Move on or keep going. I mean, sorry, stay here. Move on or stay here.
No sé cómo nos pueden responder los colegas, pero también tomar en cuenta que tenemos unos 20 minutos más de tiempo para ver si vemos más temas o si profundizamos.
C factor. Okay, we're going to move on to C factor. I got exactly one vote. So yes, the scripts are available. This same link that you're on right now or that Ling Ling shared, you can return to this anytime. It's always available. And we'd love to hear from you. So if you tell us, oh, we really, really want to do this with Landsat, we can make that script available too. It just depends on your interests. And we will absolutely share the slides that have a lot of the basis, a lot of the methods with this. If you are interested, we could also, share methods that are going into a manuscript, as I mentioned earlier. And we would love to, we'd love to hear from you on that, and we would love to collaborate if you're interested in going further with any of this. Okay, so now I'm going to share my screen, and so this is a new code, but it's in the same repository. If you don't see it, it's because I just added it, so maybe try refreshing. You can just press refresh on your reload this page. But it's the EVI percentile. The reason I just wanted to show this quickly is to explain to you why we chose the 20th percentile. And it's not essential that you run this necessarily, but you are welcome to, and welcome to experiment with it. So I'm gonna just, I'm gonna save this, and I'm gonna get the link to this specific code and put it in the chat. Oops, sorry. Okay. All right, so that's the code to this specific code if you can't see it in your repository for any reason. But so this is, if you press run, if just right away, you'll get the same kind of map that I just have produced here. And there's nothing you need to change about this necessarily, although you can run it for different percentiles if you want. And I'll show you where you do that, which is, I need to make this bigger. Sorry. Oh dear, come on. I just had it. I am not seeing, okay, here. It's this right here, sorry, line 67, sorry. This should, I should put this at the top so it's easier to find. But what this says is, where do you want to start your percentile? So this is at the first percentile. How high up do you want to go? So here I'm saying don't go less than the 50th percentile. So I want to do them in increments of 10. Okay. So if you change this, you could do it for all the way up to, the 100th percentile. And so this would give us, it wouldn't give us the 100th, but because we're doing it in increments of 10 starting from 1, it would give us 1, 11, 21, 31, 41, 51, 61, all the way up to 91. Okay. So you can, if you prefer, you can do a broader set of those, but I just wanted to show you these few because this was a problem we had when we were just doing the minimum, which if you look at is like the first percentile. So now this is Landsat. This is no longer MODIS. We found that Landsat was sort of better at capturing the microscale differences that really matter to sediment retention. And so this is finer resolution data, so it does take a little bit longer to run. But this is what the first percentile, or what you might consider to be the minimum, looks like for EVI. This is the lowest Enhanced Vegetation Index. So this is the lowest productivity of the year. And you see some weird artifacts here. So you see this line, and sometimes you see striping up here. If you zoom in, you see these like mottled blue areas that probably aren't real. Some of them are rivers, and that is real. Some of them is San Jose, and that's real. But then there's all these other blue areas, especially down where I've put this point, that is just very, very blue. That's very, very low EVI. It actually tells me at the console, oh, I don't, unfortunately, I think that is reporting for the 21st percentile, but it's this like strange line here, I think also makes us think that's not probably real. So we started looking at higher percentiles, and you'll see, like, as you go a little bit higher up, that splotch goes away. And so then if we do 2021, it almost entirely goes away. But we still see a lot of the variability. And then if I keep going, oh, sorry, it's just very slow to render. Okay, so that's 21. So the splotch is almost entirely gone. And if I do 31, the 31st percentile, not that much more disappears, and we start to lose some of the variability. But you can experiment with this. And the reason I'm showing you is because you can set which percentile you want to use in deriving your C factor in the next script. And so this is really just exploratory to decide, okay, we want to capture, the point of this is to capture the low period, the period that's the least productive vegetation, because that is when sediment can erode, potentially. But we don't want to take the minimum, because there's noise in the sensor. And so we have settled on the 21st or the 20th percentile, but you could also experiment with other percentiles. In fact, you could also experiment with the max. You could take the 90th percentile and say, maybe I want to see what kind of relationship there is if I do that. Okay, so this is the EVI percentile. And now the EVI C factor, oh, sure, I'll say that. This is the C factor code, okay? So just like with Ling, what Ling showed you, we put some variables at the top that you can change. And in this case, there aren't quite as many that you might be interested in changing. It's basically what percentile do you want to use, and what is the year of that you're most interested in. Okay, so you can do this for any number of years. And so I'm just going to run that. And in this case, there's this little geometry here that if you want to just see, oh, what is that? Google Earth Engine doesn't let you hover over a raster the way that QGIS does, unfortunately. So you can't just see what values are, but you can just rerun. It's not that slow to run, and you can move your point around by just deleting that geometry and creating a new one. I'll show you what that looks like. So this is a point that's 0.5 for. You can just drop a new point anywhere. And maybe I want to do it in something that's much lighter. Like here. Hang on. Yeah, we'll try it right there. So then if we run it again, it'll give me a new value. And this is how you can move around. Oh, that's the reason that's light is because it's actually null. So we'll erase that geometry. And we'll try this one maybe right here. And that's telling us, that's reporting what the C factor is in that location. So the two layers here that you can look at is this is the C factor according to the transformation I showed you, and this is the EVI at that percentile. If you wanted to show, like, we want to do maybe a 90 percentile instead. It'll look a lot different, a lot greener. And so this would be like showing us, and I'm not sure, to be honest, I don't know if the C factor transformation makes as much sense for the max because we haven't found as much variability in it, but you could play with that. So let's go back to 20th percentile. Okay. And you can see that, you know, they're highly related, where the EVI percentile is less green, so lower, the C factor is higher. Let's zoom out a little bit here. And just like for the ecosystem functional diversity, you can run this C factor, and you could add it as an asset to say that this is C factor 2019, 20th percentile. And actually, I think, hang on, I'll run that. It will take a little while, and we might want to go back to Ling Ling's. Because the one other thing I'll show you, let's let that run and we'll come back to it. One other thing that I'll show you that we can change and we can play with is how we decide to set, hang on, let me go back to this presentation to show you this relationship. You can also play with these variables. So in the code, there's lambda and alpha are these two variables in this distribution. So those are, if you set them differently, you know, if you set, you can make this relationship much steeper or much gentler, and that gives you different C factors. And those are, I think, interesting things to try out. Is sort of you could think of them as like calibration against observed data to see what gives you the best fit. So we're going to come back to this and I'll show you how to set lambda and run it again, but let's let that first one run first, and then we can make a comparison. So Ling Ling, I'm at, oh wait, hang on, I see I have some. I'm sorry, so how do we, apart from the year, how do we, what information, what is the information based on? Is that the question? I'm sorry, can Rafa or Thais help me?
Yes. Dice, starting from what year, bueno, perdón, está en español, pero Thais, dale vos, a partir de qué año se cuenta con información de la base de datos, en la base de datos.
Good question. Okay, so we have this from 2001 to 2017 because we're using a specific product, the Landsat 8. Wait, was it Landsat 7? Ling Ling, which one are we using? Hang on, let me look to see what we're, yeah, Landsat 8. So Ling Ling, can you help me, remind me when things, so you can do it for earlier years. Landsat goes back a lot further, but you'd have to, we would import a different Landsat product to do that. And if that's an interest, we could absolutely add that, just say like, you know, add all of those variables up front and then just specify which one you want to use based on the years. That would be super easy to add. Thanks for that question. Ling Ling, can you just remind me what the years are?
Oh, you mean Landsat 8?
Yeah, how far does this one go back versus you in Modis, it goes back to 2001. And so you were doing 2001 to 2017, but for Landsat 8, it doesn't go back as far. So you'd have to switch to 7, right?
Yes, so let me quickly check to give the accurate number. Landsat 8. Yeah, so I just go back to the Google Earth Engine to say Landsat 8 tier 1. Go back to the 2013. But you might want to start from using 2014 because 2013 started from the April.
Okay. Cool. Okay, so why don't we go back to you while our C factor is running, and let's compare the functional diversity. And then I realize we do need to just show them how they can load the 2 assets. And we should have some closing remarks real quick. Hopefully we can come back and I can show you the how to change lambda and alpha too.
Sure. Yeah, so share my screen here. Yeah, here is my eyesight. Yeah, so yeah, so this is we just generate the EFT mode is national scale and local and EFT. Yeah, so you mean so Becky, do you mean you want to me add these 2 assets?
Yeah, can you show how to look at them side by side?
Side by side. First, I can add, like for example, if there are in this asset, like there are 3 buttons here. There's one like the right arrow. You can click this one. You can add into the code. Like I need to change the name. The EFT national scale. And I also can click this arrow to EFT, the local scale. So we can add these 2 things. But what do you mean side by side? Like the show the map here?
Yeah, like can you display them, or do you have to write more for that?
Neither like we need using this function called map layer. Like
okay, got it. Yeah.
Yeah. So for example, like I can go to here. Yeah, so this is a map layer. We can using this function. We can simply add 2 map layer here. Map layer, and then the first one it is a EFTCR. Yeah, we can do this, and then we can add to another one. Yeah, yes, local. So the middle parameter it is for color thing. So we can save our code and run again. Yeah, so now you see the EFT local and yeah. So this is a EFT local. Maybe I can do national first, then I add the local on the top. One thing I want to add, like so this is how do we show like the 2 maps from the local and the national, but the map here is not that accurate because when I run the local scale, yeah, I using this local one, but it's not exactly like the geometry I just draw. Does it make sense? So you like when you do your test or your study, you want to make sure this is a code. This is this phone number, just the one generated from previous one. Like the here, I just to save the time, I didn't exactly change this phone number.
Right.
Yeah.
Yeah, good point.
Yeah.
But so yeah, so that's where we're at now is trying to understand how robust the diversity is when derived at different scales. And we'd be really interested to hear from you if you have applied this in a region of interest for you and it makes sense or it doesn't make sense. We'd love to hear either way. Okay, we're at the hour. I just want to show you one last thing and then we'll have quick closing remarks. I just realized that I should have added these variables up front so they were easier to see. Are you seeing my screen again? Yeah. Okay, so I just did do that. And if you want to basically refresh and go back into the repository, you'll now have these variables up here. They were down here like on line 70 before in this function where we're applying this again, right? So I wanted to make it easier for you to actually edit this. And so now you can go in and you can try different. I put the 3 that we looked at before, just because those were interesting. Those were good for us to test, but you could certainly try different ones and see what the behavior looks like. Yeah, so I think, you know, we'd love to keep this conversation going. As we said, that this is just the end of a grant, but I think it's hopefully one step in a long collaboration with the ministry and with any of you who are interested. And I guess we should ask Rafa for any closing remarks. And I just want to share my email with you one more time. I will do that while Rafa is speaking so that you have so you have our emails. Oh, I'll just put them in the chat. That's easy.
Muchísimas gracias, Becky y Lindley, por esta capacitación, este entrenamiento. Ha estado muy interesante y sé que es un reto hacer este tipo de entrenamientos prácticos utilizando estos medios virtuales. No obstante, creo que ha salido muy bien y me parece que podemos eventualmente en el futuro seguir haciendo este tipo de cosas. Sabemos que estamos en un cierre de un proceso, pero la relación ha sido muy buena. Estamos muy contentos con todo el trabajo que se ha tenido. Esto es información de muy alto nivel científico para nosotros y requiere que muchas más personas en nuestro país puedan tener este conocimiento a su alcance para ponerlo en el servicio del país y de tomar mejores decisiones. Por eso ha sido para mí lo más importante es que ustedes, las personas que están ahí participando, hayan estado con nosotros, hayan recibido esta información, que si tienen dudas, si quieren hacer algún tipo de seguimiento, no duden en ponerse en contacto con nosotros para que podamos apoyarles en eso, ¿verdad? Hay una gran apertura. Becky, Lindley, todos son increíbles personas que trabajan muy bien, de una forma muy profesional y sobre todo también muy amena. Entonces podemos aprovechar esta oportunidad. Yo he tenido el gusto de trabajar con varios de ustedes, de los que están ahí conectados, y sé que somos personas con muchas capacidades, muchas oportunidades, y estamos seguros que con Stanford podemos potenciar esto. No solo los que estamos hoy, sino también las personas que van a ver esta grabación. Sabemos que la naturaleza nos apoya en muchísimas formas, muchas de ellas son invisibles, y es nuestra responsabilidad poder hacer evidente ese valor que tiene la naturaleza, la biodiversidad, para garantizar ese bienestar de nuestra sociedad, que al final de cuentas es lo que estamos buscando con esto, el bienestar de las personas y de los ecosistemas. No quiero extenderme mucho porque ya estamos sobre tiempo. Hay hay demasiada información, con Inves, con Google Earth Engine, con los papers que vienen, con los videos que se han hecho. Más bien el reto aquí es cómo, y lo que nos estamos buscando, los siguientes pasos, cómo poner esto ya en el uso práctico. Este año logramos incorporar parte de los resultados en un proceso de mapeo de áreas esenciales para el soporte de la vida que se hizo para el Plan Nacional de Adaptación. Y hay también otros esfuerzos que nos gustaría seguir fomentando, el uso de esta información para las cuentas ambientales, para determinar ese valor del capital natural que tiene nuestro país. Y en general, si ustedes tienen más ideas, por favor, compártanlas y usémoslas en estos esfuerzos. Hasta ahí llega la actividad y nos gustaría, Becky, si podemos hacer una foto. No sé si se puede pasar a la gente como panelistas.
I would love that. Is there a way to to put the cameras on? I don't know how to. I don't know how to allow that. I can allow to talk, but it looks like I can't.
Becky, es que ellos tienen que ser panelistas para poder
okay.
salir.
Unfortunately, Ling Ling had to leave. I'm so sorry. And Cindy had to leave. We should have done it at the beginning. I'm so sorry.
Yes.
So sorry. I'm happy to take a photo with you, Rafa. We could do it. You know what? We can also we'll get a picture. I know what we'll do. We'll take a screenshot of the beginning from the recording when Cindy and Ling Ling were both here. I promise I will do that right after this. Thank you, everyone.
No, era para tener...
Sorry.
Perdón. Gracias. Gracias a todos. Pasen bonito día.
Muchas gracias.
Chao.
Adiós.
Adiós.
Muchas gracias.
Gracias. Gracias por los comentarios también ahí en el chat. Estamos en contacto.